So we talked about how instrumental variables can be used as our fourth and final approach to solving the non-compliance problem in experiments. So let's look at that in action with the Oregon healthcare experiment. So here's our table of results that we looked at earlier. And before, we examined this column here, the effect of lottery selection. So this was our intention to treat analysis, where we redefined the treatment variable from receiving Medicaid to just being given the option of receiving Medicaid. And remember, over here, each of these different rows are different outcome variables that we might be interested in, like what's the effect of getting the option of having Medicaid on whether you have a positive depression screen or not. Now, we don't necessarily care about what the treatment effect of having the option of getting Medicaid is. Instead, we really care about what the treatment effect of having Medicaid is on whether you have a positive depression screen or not. That's what column 3 does. But we have noncompliance. So how do we do this? Where do these numbers come from? Well, if we look down here in the footnotes, we can see somewhere over here, column 3 reports the local average treatment effect for insurance coverage as estimated by instrumental variable regression. Say 2 points. First, estimated by instrumental variable regression. That's a little vague, but what they mean is they're doing two-stage least squares, and they make it clear in the body text of the paper that that's what they're doing. Second, they say local average treatment effect. Okay, so they're getting some kind of average treatment effect. We'll talk about what exactly this local word means here in a later module. So all of these numbers in column 3 are two-stage least squares estimates of the treatment effect of having Medicaid on different outcome variables. And they're computed using two-stage least squares. So the first thing you should notice is let's compare them to the intention to treat numbers. So let's just look at the depression measures. If you compare the estimates, we see that all of the two-stage least squares estimates are larger in magnitude than the intention to treat estimates. So minus 9.15, that's a lot larger than minus 2.21. So why might the magnitude be larger? Well, what is intention to treat doing? Intention to treat is saying that there's a lot of people who didn't comply with their treatment assignment. We said, here, you can have Medicaid. And they said, no thanks. But what we did was we kept them in the treatment group, even though they didn't actually get Medicaid. So if having Medicaid actually has a positive treatment effect, then these people who didn't comply with the treatment assignment, they're included in our treatment group, but they're not actually receiving any of the positive benefits of treatment. So that's going to bias our overall effect estimate downwards, closer to 0. And once we solve for this problem by using the instrumental variables analysis, we'll get a larger effect. So that's exactly what we see happening here. The intention to treat numbers are all smaller than the two-stage least squares estimates. Now another way to think about this difference in magnitude is to remember how the indirect inference estimator works. Now that's not how we got these numbers, but the intuition is going to be basically the same. So the indirect inference estimator starts by looking at the correlation between the outcome variable and the instrument. Well, that's actually exactly what this column here shows us, the intention to treat analysis. Why is that? Well, because when we're analyzing non-compliance in experiments, our instrument is the treatment assignment variable. If you were assigned to get Medicaid or not, that's the instrument we're using. And then our treatment is whether you actually received Medicaid or not. And our outcome is any one of these. So this column here is the regression of the outcome on whether you were assigned to treatment or not. That's exactly the reduced form regression used in the indirect inference estimator. So getting this number is the very first step. Then, in the second step, we look at the relationship between the instrument and the treatment. So whether you actually got treatment or not, and how does that compare to your outcome variable? That's called the first stage estimator. And that's shown in this table over here, table S9, the first stage. So this is our second step. So here on the left-hand side, we have different measures of treatment. So for example, let's just focus on the first line. Did you ever get Medicaid during the study period? So did you receive Medicaid? That's our treatment. So this is now our outcome variable because we want to know what's the effect of the instrument being assigned to receive Medicaid on the outcome, actually receiving Medicaid. So here we see that in the control group, some people still managed to receive Medicaid even though they weren't assigned to it. Then if we look here, this second column shows the difference in the percentage of people who received Medicaid between the control groups and the treatment groups, or the lottery winners, the people who were assigned to get Medicaid. So there's a very large number, 24%. So winning the lottery greatly increased your chance of actually getting Medicaid. It didn't push it up to 100% because we had noncompliance, okay? But it largely increased it. So this number here shows us that the relevance assumption in the instrumental variables analysis holds. The instrument actually did cause people to get treated, to actually receive Medicaid. So the indirect inference estimator is going to take this number here, or similar numbers, and then adjust this number here to get this number here. Okay? So we take our reduced form numbers, the effect of the outcome on the instrument, adjust it using the effect of the treatment on, the effect of the instrument on the treatment to get the actual effect of treatment on outcomes. That's how the indirect inference estimator works. So that's another way to interpret the increase in magnitude between this one and this one. So now we've gone through basically all the analysis in the Oregon Healthcare Experiment paper, and you can pick up the New England Journal of Medicine that has that paper published, and you can read every single piece of it and perfectly understand it.